Welcome to The Explainer. Today, we're diving into something pretty incredible. We're looking at how a seemingly simple, sharply spiked weed with bright pink flowers is literally transforming the landscape of integrative oncology. We're going to pull back the curtain on the science behind milk thistle and explore its profound emerging role in cancer treatment. Okay, here is our roadmap for today. First, we'll look at its history as the ancient liver healer. Then, we'll meet the active compounds, explore its cellular weapons against cancer, see how it acts as a real team player in modern therapy, and finally, we'll tackle the clinical challenges and limitations. So, think about this for a second. How exactly did a prickly weed, one native to the Mediterranean and used way back in ancient Rome, become a major focus of modern cancer research? I mean, it is a massive leap going from an ancient folk remedy to a primary subject in cutting-edge oncology studies, right? Let's figure out how we got here. All right, Section 1, the ancient liver healer. Historically known as Silybum marianum, the seeds of this plant were actually prescribed by ancient Greeks and Romans to protect the liver from toxins. For centuries, European herbal medicine leaned on it heavily for detoxification and to defend against liver damage from things like alcohol and environmental pollutants. Moving right along to Section 2, meet the active compounds. To truly understand its power, we have to look past the plant's milky white sap and zoom in on the actual biochemistry. So what's doing the heavy lifting here? Milk thistle seeds contain this complex mixture of compounds known collectively as silymarin. But within that mixture, there's a specific compound called silibinin, and it is the absolute standout. It's the most pharmacologically active component of the bunch. Silymarin, and specifically the silibinin, drives the profound antioxidant and cellular detoxification effects we're looking at. It physically repairs the liver by stimulating protein synthesis, and it essentially changes the outer layer of liver cells to block toxins from ever getting inside. Which brings us to Section 3, cellular weapons against cancer. This is where we shift from simple liver protection to complex tumor suppression right at the cellular level. This is where the oncology applications truly take off. Researchers have mapped out what is essentially a multi-targeted attack against malignancies. First up is cell cycle arrest. Silymarin basically slams the brakes on cancer cell division. Next is apoptosis, which is programmed cell death, and it triggers this by activating key proteins. Finally, it actually halts metastases by suppressing the very enzymes that allow tumors to break away and spread to other tissues. And the arsenal goes even deeper. Silibinin actively disrupts cancer signaling to literally starve tumors. By downregulating something called VEGF, it stops the tumor from building new blood vessels, which is a vital process known as angiogenesis. It also prevents the cellular transitions that let cancer invade surrounding tissue. And get this, it even recruits your body's own immune cells, specifically macrophages, to actively fight the cancer. For example, in lab studies with mice that were genetically predisposed to getting skin cancer from UVB radiation, just adding silymarin to their diet acted as a complete antidote. They simply didn't develop the cancer. Absolutely incredible. Now for Section 4, a team player in therapy. Milk thistle acts with high selectivity through this really unique dual-action motif during conventional cancer treatments. Think of it like this. In your healthy tissue, silymarin acts as a shield. It protects the liver's stores of glutathione and defends your healthy tissues from the severe, toxic side effects of radiation and chemotherapy. But over in the tumor tissue, it acts as a weapon, actually sensitizing prostate and breast tumors to those very same therapies. It effectively makes the treatment harder on the cancer, but much easier on the patient's healthy biology. When you combine it with powerful traditional drugs, the synergistic results are fantastic. With a drug like doxorubicin, silymarin enhances cancer cell apoptosis while actively reducing cardiotoxicity, meaning it limits the toxic damage to the heart. When combined with cisplatin, it enhances the drug's overall efficacy while reducing nephrotoxicity, which protects the kidneys. This is exactly why many oncology experts point out that it doesn't blunt the effectiveness of chemotherapy, it actually amplifies it, all while mitigating the collateral damage. But, of course, true scientific inquiry requires strict objectivity. So, Section 5, challenges and limitations. We have to examine the very real hurdles of using this natural compound in clinical practice. Take a look at that staggering number, 480. That is how many grams of raw milk thistle seeds you would need to consume every single day just to hit an active 11-gram clinical dose.
because the seeds contain only about 2.3% silymarin, trying to get a therapeutic amount simply by eating the raw seeds is mathematically and practically impossible.
And volume isn't even the only issue here. Silymorin is not easily absorbed by the body. It has extremely low bioavailability. On top of that, it can interact with P-glycoprotein efflux mechanisms, which basically act like cellular pumps. This is a real risk because it can alter how your body clears out essential chemotherapy drugs. Add in genetic variations and CYP450 liver enzymes that change how the drug is metabolized from person to person, and well, you've got yourself a very complex pharmacological puzzle. But researchers are on it. They note that integrating nanoformulations and personalized medicine may significantly enhance its efficacy. This tells us the future lies in overcoming these biological hurdles with advanced delivery systems. Scientists are actively developing things like polymeric nanoparticles to create tailored, highly absorbable therapeutic regimens that can completely bypass these limitations. So, I'll leave you with this provocative thought to chew on as we wrap up this explainer on the remarkable potential of integrative medicine. How will the evolution of drug delivery transform these ancient botanical shields into the precision cancer weapons of tomorrow? The gap between ancient herbalism and modern targeted oncology is closing fast, and it's fascinating to watch. Thanks for diving into the data with me today, and I hope this gave you a clear, focused look at where the science stands right now.